All right, let's look at solving one-step equations. Go ahead and take out your note-taking guide that was handed to you on your desks today in class, and let's go over the note-taking guide. Also get out a sheet of paper. You might need it to practice some additional problems. All right, so if I'm looking at one-step equations, let's review some terms really fast. What is an equation? Well, notice here I've got this equate. To write an equation just simply means to write an expression using an equal sign. An equation can be 8 plus 1 equals 9, or it can be 8x equals 64. Anything that uses an equal sign is an equation. So you know how to solve 8 plus 1 and 8 plus 9. That's 17. 17 is the solution. A solution is a value, or sometimes it can be more than one, for a variable that make an equation true. So let's break this down. If I look at a variable expression, 3x equals 15. I want to know what x equals. I'm looking for the solution for x. In order to solve this, it's going to require using some properties. Let's look at the addition property of equality. Down here, this guy. All right, according to the addition property of equality, if A equals B, then I can add the same thing to A, in this case C, that I also add to this side of the equation, to B, and it's going to be true. Let's look at a number version of this. If I have 8, let's say I have 8 equals 3 plus 5. This is a true equation. Let's say I want to add 2. Well, for this equation to remain true, I have to add 2 to both sides. What would happen if I only added it on the 1? Then I'm saying that 8 equals 8 plus 2, and that's not true. 8 does not equal 10. All right, since that doesn't work, I end up having to add it to both sides. If you want to keep your equation true, you have to add the same thing to both this side of the equation and this side of the equation. Let's look at solving some math problems using this property. If I have x and I want to subtract 3, and I know that it equals -8, somehow I have to get x by itself. I need to find a solution where x equals something. So how do I get here? In order to get here, I'm going to use the addition property of equality to solve this. So what that means is I'm going to add the same thing to both sides. What could I possibly add over here to get my x to go away? Well, since I have a -3 over here by x, what is the opposite of subtraction? The opposite of subtraction is addition. All right, this brings up another important term, inverse operation. Let's come back up here to our blue. An inverse operation is simply an operation that undoes. It's operations that undo each other. So let's come back down here and look at that definition in the context of this problem. If an inverse operation is an operation that undoes itself, what operation am I doing here? Hopefully you said I'm subtracting. And since I'm subtracting, I want to look at the inverse operation of subtraction. What is its opposite? Well, the opposite of subtraction is addition. So I'm going to end up adding 3. So x minus 3 plus 3 equals negative 8. But according to this property, what I do to one side, I have to do to the other. So I have to add 3 here too. Let's see what I get. X, negative 3 plus a positive 3 equals 0. And negative 8 plus 3, if I have signs that are different, I end up subtracting them and taking the sign of the bigger number, which in this case is negative. So I now know that x, since it's by itself, equals negative 5. All right, let's plug this negative 5 back into my original equation, and let's see if it works. Negative 5 minus 3 equals negative 8. When I have two numbers with the same sign, I add them together and take the sign they share. They're both negative. Is it true that negative 5 satisfies this equation? Yes, it is. Negative 8 equals negative 8. So this right here is my solution for x. X equals negative 5. All right, let's look at one more together. Make sure you copy this problem down on your paper. And let's do this one. M minus 10 equals 2. I want you to solve for m. What this means is, again, you're going to have to isolate m, get m by itself. So how do I isolate m? Well, I have to use my addition property of equality, so I need to find what operation I'm doing on the same side as m. Well, the operation here is subtraction, so I need to do the opposite of subtraction, which is addition. So I'm going to take m minus 10, and I'm going to do the opposite. I'm going to add 10. And what I do to one side, I also have to do to the other to keep it all balanced. So I have to add 10 over here by my 2 as well. So now these end up canceling out, and I get m minus 0. You could have written it as m plus 0. That's fine too. Now, what is 2 plus 10? It's 12. So the solution for my problem is m equals 12. Just to check, I'm going to end up plugging this back in here. So I'm going to take my 12, and I'm going to see if I subtract 10, does it equal 2? Yes, it does. Therefore, my solution works. All right, I would like you to do, let's look on page 28 of your note-taking guide. It's the back side of this. I'd like you to do x plus 5 equals 6 and show your work. And then I'd also like you to do negative 18 equals 6 plus w. Those are problems B and D. Pause me, and then let's check your work when you're done. All right, hopefully you got, for B, x should have equaled 1, and for D, W should have equaled negative 24. All right, let's look at doing one that involves some reciprocals. Actually, no, you can handle C. Go ahead and also do C for me. 2/3 plus y equals 1/4. All right, and be prepared to show your work. We're going to check this one together, so pause me until you're done with this one. All right, hopefully you're ready to check now. Let's look at this. I have to get y by itself over here, so I have to do something to remove this 2/3. Well, hopefully you recognize that 2/3 plus y is the same thing as y plus 2/3. So I'm just going to simply rewrite this to show that it is an addition problem. What is the inverse of my operation here? Well, the opposite of addition is subtraction. So I'm going to end up subtracting 2/3 from both sides. Remember to do it to both sides. Okay, so my 2/3 end up canceling out here, and I'm left with y equals 1/4 minus 2/3. Can't leave it there. All right, you've got to put your denominators, make them equal. 12 works for both of them. All right, this becomes 3/12, and this becomes 8/12. What is 3/12 minus 8/12? Well, hopefully you remember that you're going to subtract 3 from 8. You're going to get 5 and take the sign of the bigger 1, which is negative. It's negative right here. So this has become a negative 5/12. If you have questions, rewatch this section. Rewind me and restart. Otherwise, we are moving on. Let's look at the subtraction property of equality. We just did a problem like it. This problem with the 2/3 plus the y. How did we do this? I ended up having to subtract my 2/3 here. Why did I subtract my 2/3? Because the process was an addition process, and subtraction is the opposite of addition. So hopefully you figured out that just like I have my addition property of equality, I'm also going to end up working with a subtraction property. And my subtraction property, all it says is if A equals B, then A minus C equals what? Well, hopefully you realize that I subtracted C from this side, so I also have to do it here. So for example, if I have x plus 3 equals 12, I want to get x by itself, so I need to subtract my 3 from both sides. These are going to cancel, and you're going to be left with x equals 9. All right, let's look at one involving a triangle here. All right, we're going to use this property. All right, let's look at using this properties of subtraction and addition with equality. So I have a triangle here, and my triangle is triangle PQR. And triangle PQR has two sides that are equal, and those are represented with these tick marks in red. If you see single tick marks on geometric figures, it means that this length is equal to this length. All right, so I know that line PQ is 11, and I know that segment PR is equal to PQ, but this is 6 plus something. Now you could probably intuitively find A, but we're going to do this algebraically. All right, so let's look at what we've got. If you're following along in your note-taking guide, this is page 27 at the bottom. All right, I have 6 plus A equals what? Well, hopefully you said it equals 11, because 6 plus A is right up here, and it's equal to this side right here, which is 11. So if 11 equals 6 plus a, I now have to solve for a. How do I do it? I have something on this side that I need to get rid of. I want a by itself. If I want to keep a by itself, I've got to get rid of this 6. How do I get rid of it? Well, hopefully you recognize that 11, this is the same thing over here as a plus 6. It might be easier to think of it this way. So I'm adding 6 to 11. So in order to add 6 to 11, I need to get a by itself. So I need to end up subtracting the 6. What I do to one side, I've got to do to the other. Now I can solve. What is 11 minus 6? Hopefully you said it's 5. And that is a plus 0, because 6 minus 6 is 0. So a equals 5. This should be my solution. Let's double check and plug it in. What is 5 plus 6? Hopefully it's 11. This is the solution to my problem. Cool beans. All right. I would now like you on your own paper to look at this triangle. This is not on your note-taking guide. This is extra. All right, I have tick marks. Hopefully you remember what those mean. This side is a plus 4.2, and this side is 15. This is triangle A, B, C. So line AB equals part BC. All right. 15 equals A plus 4.2. Solve for A. Pause me, write this on your own paper, and unpause me when you're done. Hopefully you got 10.8 equals A. If so, give yourself a pat on the back. Hopefully you recognize that you have to end up doing the inverse of this guy, which is subtraction. What you do to this side, you also have to do to this side. Notice that if I'm subtracting 4.2, I'm not just going to put 4.2 minus 15. That's not the same, because I've just made 15 negative. I end up writing out 15 minus 4.2. I'm taking the 4.2 away from the 15. Okay. Let's go ahead and let's move into the multiplication property of equality. Actually, I changed my mind. Before we move on to multiplication and division property of equalities, I'd like you to do these 6 problems on your own paper. Copy the problems over, solve them, show me your work, and be ready to show me these in class. The numbers are off. These aren't 1 through 6. They're 2, 3, 4, 6, 15, and 13 because they correspond to numbers of problems in your book. Please do these 6 on your own, and then unpause me when you're ready to move into the multiplication and division properties of equality. All right, let's look at the multiplication property of equality. If A equals B, and I want to take number C and multiply it times B, in order to keep my equation true and equal, I have to do it to both sides. All right, let's look at this a couple of ways. I want you to also see that here I used a dot, and that represents multiplication. Here I just simply wrote the letter beside the other letter. If you see B and C together, it means B times C. It also could be written as B in parentheses times C in parentheses. These are a couple of ways you're going to start to see multiplication. Don't ever use X's from here on out. All right, so let's look at this. If I have something that looks like this for A, if A is 6 halves, and I want to put that equal to something, I'm going to say 6 halves equals 3. We know that's true. 2 divided by 6 equals 3. All right, but I want to multiply 3 by 4. Well, 6 halves does not equal 12. In order to make this true, I'm going to end up having to multiply this side by the same number. All right, at this point, I know that 4 times 6 halves equals 12, and we're still good. I'm balanced. The way I had to do that was by by doing to one side of the equation exactly the same thing that I did to the other. Let's look at using this fact to solve multiplication problems. All right, if I have, and I'm going to give you a really gnarly one to start. Let's say I have a negative r over 4, and that equals negative 10.4. Ooh, that doesn't look pretty. All right, this is saying that r divided by 4 equals negative 10.4. So what is the operation I'm doing on the side with r? Hopefully you notice I'm doing division. The inverse of division is multiplication. So I'm going to end up needing to multiply this whole thing by some number. Well, what number could I possibly multiply in here so that r gets by itself? Well, I'm going to multiply by what I'm dividing r by. So I'm going to multiply by 4. What I do to one side, I have to remember to do to my other side. Protect your negative with parentheses, so we remember to keep it there. If you're writing this on paper, use a red pencil or red crayon to make sure you keep your negatives negative. All right, let's look at doing this math now. I have 4. I'm going to set that over 1. And at this point, I know that my 4's cross out. And I'm left with 1 times negative r, which is negative 1r over 1, equals, if I have a negative times a positive on this side, it's going to end up being a negative. And hopefully I get 6, carry the 1, 41.6. All right, notice that 1 over 1 is the same as just r, but my r is negative. So negative r equals negative 41.6. All right, this is where I need to be careful. I still don't have r. I have a negative 1. I end up needing to divide negative 1. Remember, there's like this imaginary 1 out here. I'm going to have to divide this by negative 1 and divide this by negative 1, because what I do to one side I have to do to the other. And I get r equals a positive 41.6, because a negative divided by a negative is a positive. You could have skipped a step if you had recognized way back up here that you could have just divided by negative 4. All right, let's have you looking at this example. I would like you to do the following, and these are in your note-taking guide on page 29. Let's do negative 1/4 m equals 8. Do this on your own. It's problem number 3A on page 29. When you're done, unpause me. All right, welcome back. Hopefully you recognize that negative 1/4 m is just the same thing as negative 1m over 4, and that's equal to 8. You could have also written it as 1m over negative 4 equals 8. It doesn't really make a difference. At this point, what I'm going to end up doing is I need to get m here by itself. So I've got to get rid of this 4. How do I do that? I can't just delete it. I've got to do the opposite of whatever I'm doing to my m. The operation I'm doing to my m is division by this bar. So I'm going to do its opposite, or multiplication. So if I have negative 1m divided by 4, I'm going to multiply this whole thing by my denominator, which is 4. If you did it this way, you can do it by negative 4. And what I do to one side, I've also got to do to the other. So I got to multiply my 8 by 4. Or over here by -4. Alright, at this point, these cancel out. And I'm left with -1m equals 32. If you did it over here, you'd say, oh, my -4 crosses out with my -4, and I'm left with 1m equals -32. At this point, you recognize 1 times m is just m. M equals -32. Over here, I have this -1 though, so I'm not quite done. I've got to divide by -1, and what I do to one side, I've got to do to the other. Alright, what is -1 divided by -1? Cancels out, leaving just m. And 32 divided by -1, hopefully it's just -32. I get the same answer here as here. Alright, and I could plug this back into my solution and I would get 8, because m can only equal -32. It is the only solution I can have to make this true. Okay, I would like you now to work, well, let's do some multiplication and more division properties. So the division property of equality, flip back to page 27 on your note-taking guide. Division property of equality states that if A equals B, and also, by the way, C cannot be 0. If A equals B, then if I divide A by C, I also have to divide B by C, and they will still be equal. Let's look at an example of this. If I have A being 3 plus 1 and B equals 4, if I divide this side by 2 and I want to keep this accurate, I got to divide this by 2 too. And is it true that 4 over 2 equals 2? Yes, it is. As long as I divide both sides by the same thing, I'm golden. Let's use this to solve, remembering that I'm going to use this to do the inverse of multiplication to solve an algebraic expression. So if I have, let's look at example 4 on page 29 of your note-taking guide. Alright, it's asking me to solve -6m equals 42. Ruh-roh, I've got a negative here. How can I possibly get m by itself? What is going on here with -6m? What operation am I doing? Am I adding, subtracting, multiplying, or dividing? Hopefully you recognize that this is the same as multiplication. I'm multiplying -6 by m. This is, if I rewrite it to make it a little bit clearer, it's -6 times m equals 42. The opposite of multiplication is division, so I need to divide this by something to get m by itself. Well, I want to divide away -6. What I do to this side, I've got to do to this side. So I'm left with m equals 42 divided by -6, which equals -7. If I were to plug this back in to my original equation for m, does it work? -6 times -7 equals 42. Well, -6 times -7, both the negatives end up making a positive, so I get 42. Does it work? Yes, it does. This is my solution. So when I have, to summarize, let's look at our examples. When I have a problem that is an x minus 3 plus 8, this guy here, x minus 3, I'm subtracting here. So I end up having to do the inverse and add. And what I add to one side, I've got to add to the other. If I have a problem where I am adding something to x, I need to end up doing the opposite of the addition, which is subtraction. So I subtract 3 from this side and also this side to get x by itself and get my solution. If I have a situation where I am where I'm dividing, here I have negative r divided by 4. If I'm dividing, I end up having to multiply, and what I do to one side, I've got to do to the other, and then solve it out for my solution. If I have a situation where I am multiplying something times my variable, the opposite of multiplication is division. You have to divide it away. What you do to one side, you got to do to the other. Then solve it and get your variable. Okay, let's do some practice problems now. I would like you to do on page 29 of your note-taking guide, letters C and D. You get 3p equals 12 and negative 8 equals 5y. Do them on your own. Show me your work. All right, welcome back. Hopefully for p, you got p equals 4, and for y, you got it equal to negative 1 3/5. If you didn't get this, go back and rework this problem and see if you can figure it out. When you're done with that, let's do this problem that involves using reciprocals. All right, welcome back. Let's say I have solve 2/5 y for negative 10. Well, if I'm solving it, I'm finding the one solution that works for y, so I got to get y by itself. This time I've got a fraction going on. I've got multiplication because this is like 2 times y, and it's all divided by 5. This is icky. All right, so I've got to both multiply and divide. So if I have 2y divided by 5 equals negative 10, 2 times y, and it's over 5. That's how I got this guy. Okay, now let's solve this first. I have 2y divided by 5. How do I undo division? Hopefully you said multiplication. So I'm going to end up having to multiply 2y over 5 by 5 over 1. And what I do to one side, I've got to do to the other. All right, let's see if we can solve this. At this point, my 5's end up crossing out, and I get 2y equals negative 10, which is over 1, times 5 over 1. All right, let's solve 2y equals, multiply these across, negative 50. Okay, now I end up having multiplication going on because 2y is the same as 2 times y. So my operation here is a multiplication. The opposite is division. So to get y by itself, I've got to divide this whole side by 2. And what I do to one side, I've got to do to the other. All right, at this point, my 2's cross out. I've got my y, and negative 50 divided by 2 equals negative 25. There is an easier way. Well, potentially easier, faster way. Let's look back up here. Notice that I had a fraction. I was both multiplying and dividing here. I could end up 2/5 y equals negative 10. I'm going to multiply this whole thing by the reciprocal, 5 over 2. And remember what I do to this side, I've also got to do to this side. So I'm going to multiply by 5 too. And let's check what I've got. These cross out. I got 1s. So I'm left with just my y. and negative 10 times 5 over 2, y equals negative 50 over 2, which we saw was negative 25. It's a little less paper to do it this way, but you have to remember to flip your reciprocal and multiply to both sides. All right, at this point, I know this video has been long and you are tired, so now I would like you to finish out page 29 on your note-taking guide. I'd like you to solve the rest of those problems on the check understanding. So everything over there should be filled out. You do not have to do the number 2 on page 28, but all of the check understanding should be done. So your note-taking guide is ready to go. You're ready to come back to class tomorrow and do 2-step equations.